kinetic energy, maximum velocity, stopping potential depends upon is an instantaneous process. Very important expression. Work function is h nu naught. The so-called elastic collision is between two microparticles. Hello students. Thought for the day: do not allow others to lead you. Make best use of your knowledge. Amass your potential, and success with wings is at your foot. This is SD Sir from the Temple of Excellence, continuing the discussion on dual nature of matter and radiations. My dear students, in the previous class, we beautifully understood Einstein's explanation to the mechanism of photoelectric effect, where we told photoelectric effect is the result of the collision between the incident photon and the electron in the metal. And what was the nature of the collision? Elastic, where the photon transfers all its energy to the electron. And how did the electron make use of that energy? First, to overcome the work function of the metal, and second, to increase the kinetic energy. Therefore, we told energy of the photon equals work function of the metal plus increase in kinetic energy. And we wrote a classical expression called Einstein's equation for photoelectric effect. Continuing my discussion today, based on Einstein's explanation, we will understand the consequences or results of photoelectric effect. ನೆನಪಿದೆಯಾ? Hertz experiment ಓದಿದ್ವಿ. We studied an experiment to understand photoelectric effect, and we jotted down 4 observations or 4 conclusions of photoelectric effect. In my today's class, based on Einstein's explanation, using Einstein's explanation, we will understand the consequences of photoelectric effect. My dear students, the very first result that was formulated was photoelectric effect is an instantaneous process. Alva? We told it is an immediate effect. As soon as the photon falls on the metal surface, in a time interval of nanoseconds, 10 power minus 9 seconds, very small time interval, electron is liberated from the metal. So my question now is to understand why photoelectric effect is instantaneous. What Mr. Einstein says is, photoelectric effect is the result of collision between two microparticles. Go back to Einstein's explanation. When photon falls on the metal surface, elastic collision is happening. And he says it is a collision between two microparticles, two subatomic particles, two particles which are very, very small in size. Therefore, it is not that today the photon is incident and tomorrow electrons are liberated. It is immediate. It is instantaneous. Liberation of electron is happening in nanoseconds. The result because the collision between a photon and an electron, the so-called elastic collision, is between two microparticles, two particles which are very, very small in size, two particles from the micro domain. Therefore, photoelectric effect is instantaneous. So, ದಯವಿಟ್ಟು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, photoelectric effect ನ ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ಅಂತ ಯಾಕೆ ಹೇಳ್ತೀವಂದ್ರೆ, ಫೋಟಾನ್ ಮತ್ತೆ ಎಲೆಕ್ಟ್ರಾನ್ ಮಧ್ಯೆ ಆಗೋ ಕೊಲಿಷನ್ ಎರಡು ಮೈಕ್ರೋ ಪಾರ್ಟಿಕಲ್ಸ್ಗಳ ಮಧ್ಯೆ ನಡೆಯೋ ಯುದ್ಧ. ಅತಿ ಕಡಿಮೆ ಸೈಜಿನ ಸಬ್ಅಟಾಮಿಕ್ ಡೊಮೇನಿನ ಮೈಕ್ರೋ ಪಾರ್ಟಿಕಲ್ಸ್, ಫೋಟಾನ್ ಅಂಡ್ ಎಲೆಕ್ಟ್ರಾನ್. Therefore, it is an instantaneous process. Second one, we spoke about the existence of threshold frequency. There is a minimum frequency below which there is no liberation of electrons. For every photosensitive material, there has to be minimum frequency of the incident radiations, only above which liberation of electrons happen. Why threshold frequency plays such an important role? You understand, if the frequency of the incident radiation is less than threshold frequency, the kinetic energy of the electrons becomes zero and their velocity becomes minimum. See, we wrote h nu is W plus kinetic energy. This was Einstein's photoelectric equation. Energy of the photon is equal to work function plus maximum kinetic energy. Now follow, students. If nu is less than nu naught, ಏನಾಗುತ್ತೆ? Frequency of the incident radiation is less than threshold frequency. The radiation fails to impart sufficient kinetic energy for those photoelectrons. Please to understand, if the frequency of the incident radiation is below threshold, electrons cannot overcome the work function of that metal. Why? Their kinetic energy becomes zero. Their velocity is minimum. Therefore, here W becomes equal to h nu naught. Very important expression. Work function is h nu naught, where nu naught is the threshold frequency, and hence the electrons cannot come out of the metal surface. Again I repeat, if the frequency of the incident radiations is less than the threshold defined, if nu is less than nu naught, that radiation fails to impart sufficient kinetic energy to the free electron. So the free electron cannot overcome the work function of the metal, cannot break those barrier forces. So its kinetic energy is becoming zero, velocity is becoming minimum. Therefore we say, for photoelectric effect to happen, for liberation of electrons, the frequency should be greater than threshold, so that sufficient kinetic energy can be given. Velocity of the electron increases and comes out of the metal surface. Next. Now, dependence of photocurrent on intensity. I told the intensity of radiations is nothing but number of photons incident on the metal per second. 1 second ಅಲ್ಲಿ ಮೆಟಲ್ ಸರ್ಫೇಸ್ ಮೇಲೆ ಎಷ್ಟು ಫೋಟಾನ್ಗಳು ಬೀಳ್ತವೆ, ಇನ್ಸಿಡೆಂಟ್ ಆಗುತ್ತೆ, ಅದನ್ನೇ ಇಂಟೆನ್ಸಿಟಿ ಅಂತ ಕರಿತೀನಿ. Suppose 1 photon falls, it is liberating 1 electron. So what happens? There is motion of electron, some current is constituted. 2 photons are incident, 2 electrons fall, proportionately current increases. N number of photons fall, n number of electrons are liberated, proportionately current increases. And this liberation of electron happens above threshold frequency. So we say, as the intensity of radiations increase, number of photons also increases. This increases the number of emitted electrons and photo current increases. So, photoelectric current depends upon intensity and is independent of the frequency of the radiations. But as the frequency of the incident radiation increases, kinetic energy, maximum velocity, and stopping potential increases. In stopping potential andre, we also called it as retarding potential. Minimum negative potential given to what? Anode. Why? To stop the photoelectrons from reaching the anode and causing photocurrent. So, kinetic energy, maximum velocity, stopping potential depends upon frequency and they are independent of intensity. So beautifully, the four observations of photoelectric effect is explained based on Einstein's theory. Now, we will study the properties of photons. Again, a 3-mark question. The first property I have already told, packets of energy. Photons are small, discontinuous, discrete packets of energy. You remember army people throwing shelter and food packets from the helicopter? Same way, photons are thrown to us. They are small packets of energy, discrete packets, discontinuous packets. They are also called quanta. So, photons or quanta. Next, the energy of the photon is given by E is equal to h nu. In terms of frequency, energy of the photon, E equals h nu, where h is Planck's constant, nu is the frequency of radiations. In terms of wavelength, E is equal to hc by lambda. Nu is replaced by c by lambda, where c is speed of light in vacuum, lambda is wavelength. Photons are electrically neutral. Why? And since they are electrically neutral, they cannot be deflected by electric and magnetic fields. And the rest mass of a photon is 0. 1 mark ge sumar sati kelidare. What is the rest mass of a photon? The rest mass of a photon is always 0. So photons, small packets of energies called quanta. They are discontinuous in nature or discrete in nature. The energy in terms of frequency E equals h nu. In terms of wavelength, E equals hc by lambda. They are electrically neutral, hence not deflected by electric and magnetic fields, and the rest mass of the photon is zero. So in this session, students, we have beautifully discussed the facts of photoelectric effect using Einstein's theory, and we have understood the properties of photons. The next session, we will understand matter waves. Until then, have a nice time. Thank you.